Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the details about the interrupt of 8051 microcontroller. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see some additional details about the interrupt, such as the interrupt registers IE and IP. First of all, let's summarize our previous lecture. In that lecture, we have seen that there are total 6 interrupts: reset, external hardware interrupts INT0, TF0, INT1, TF1, and RITI. These are the 6 interrupts. Each interrupt has its ROM location or its vector address, such as the reset has the vector address 0000H, INT0 has the address 0003H, TF0 has the address 000BH, INT1 has the address 0013H, TF1 has the address 001BH, and the serial communication interrupt has the address 0023H. These addresses are given. Okay. Whenever the interrupt occurs, then the 8051 microcontroller stops its current execution. It executes the current instruction and saves its address onto the stack. Then it executes the interrupt service routine. The interrupt service routine jumps to this vector table, goes to the proper address of this interrupt and execute the interrupt. Whenever the RETI instruction occurs in the interrupt subroutine, then the controller jumps to the normal program and start the main program execution. Okay, these are the steps for the interrupt. Now let's see some more details about the interrupts. 8051 has main 5 interrupt signals: INT0, TF0, INT1, TF1, and RITI. One more is reset. Okay, each interrupt can be enabled or disabled by setting bits of the IE register, and the whole interrupt system can be disabled by clearing the EA bit of the same register. That means by interrupt enable register, we can enable or disable any interrupt of the 8051 microcontroller. Okay, and we can disable all the interrupt by making EA equal to 0. Hence the EA pin is called as the global interrupt pin. Okay, the next register is input enable interrupt priority register. We can change the priority levels of the interrupts by changing the corresponding bit in the interrupt priority register. Let's see the details about each register one by one. The first one is IE register, that means interrupt enable register. The interrupt enable register is used for enabling and disabling the interrupts. This is a bit addressable register in which EA, the global interrupt enable disable pin, value must be set to 1 for enabling interrupts. Okay, that means in IE register, the EA pin or the EA bit is such that if we want to enable any interrupt, then the EA should have the value 1, and if we want to disable all the interrupts, then EA should have the value 0. Okay, the individual bits in this register enables the particular interrupt like timer, serial, and external inputs. Consider the IE register, the bit corresponding to 1, that means the activate the interrupt, and 0 disables the interrupt. Let's see the structure of the IE register. Here is the IE register is an 8-bit register. The 8 bits are EA, then dash dash ES, ET1, EX1, ET0, EX0. This is the bit 0. This 1, 2, 3, 4, 5, 6, and EA is bit 7. Okay, here we can enable any bit. That means if we want to enable ES bit, then we have to give value 1 to it. if we want to disable it, then we have to make it 0. Okay, that means by making it 1, that means by setting it, we can enable the interrupt, and by resetting we can disable the interrupt. Okay, let's see the details about each bit one by one. First one is EA, that is IE.7. The IE.7, that means if EA equal to 0, then it disables all the interrupts. No interrupt will be acknowledged. If EA equal to 1, that means if EA equal to 1, then interrupt source is individually enabled or disabled by setting or clearing its enable bit. That means whenever EA equal to 1, we can enable the serial interrupt ES by giving value it 1. Okay, the IE6 and IE5 are the not implemented bit, and they are reserved for the future use. The next bit is ES IE.4. The enable or disable the serial port interrupt. That means when EA equal to 1, ES equal to 1 means it enables the interrupt, and ES equal to 0, that means disables the serial interrupt. Okay, I hope you all understand. The next is ET1, that means IE.3. It enable or disable the timer 1 overflow interrupt. That means the timer 1 overflow interrupt means the TF1 flag overflows. That means when TF1 flag sets, then this interrupt occurs. Okay, we can set this or we can enable this interrupt by making EA equal to 1 and ET1 equal to 1. We can disable it by ET1 equal to 0 or directly by EA equal to 0. Okay, the next is EX1. It is the IE.2 bit. It enable or disable the external interrupt 1. That means INT0 1. Okay, whenever there is an external interrupt 1 occurs, or if we want to enable this interrupt, then we have to give value EA equal to 1 and INT1 equal to 1. If we want to disable this interrupt, then make INT1 equal to 0 or EA equal to 0. Similarly, ET0 enable or disable the timer 0 overflow interrupt. That means if we want to enable this interrupt, then make ET0 equal to 1. If we want to disable it interrupt, then make ET0 equal to 0. The last bit is EX0, that means enable or disable external interrupt 0. Okay, we can enable this interrupt by making EA equal to 1 and EX0 equal to 1. Then we can enable this external interrupt 0. Okay, if we want to disable it, then make EX0 equal to 0 or simply make EA equal to 0. By making EA equal to 0, all the interrupts are disabled. Okay, I hope you all understand the IE register structure. Now let's see the details about the IP register. IP register means the interrupt priority register. The priority to the interrupt can be assigned by using the interrupt priority register IP. In case when two or more interrupts arrive, microcontroller queues them according to the priority. That means if two or more interrupts are occur at the same time, that means for example consider INT0, INT1 and RITI, these three interrupts are occur at the same time, then microcontroller will execute the interrupt depending upon its priority. That means here the external interrupt 0 has the highest priority, hence this interrupt is executed first. Then these two are remaining. From these two interrupts, the external interrupt 1 has the second most highest priority. Then INT1 is executed, and then the TI/RI is executed. Okay, this is known as the priority, and we can assign the priority to this interrupt by using the IP register. Okay, let's see the interrupt priority after reset. Whenever we reset the microcontroller, then this is the default priority assigned for the interrupts. The first priority interrupt or the highest priority interrupt is external interrupt 0, INT 0 interrupt. Okay, the second highest priority interrupt is timer interrupt 0 or TF 0 interrupt. The third highest priority interrupt is the external interrupt 1, that means INT 1 interrupt. The fourth one is timer interrupt 1, TF1 interrupt, and the last priority interrupt, that means lowest priority interrupt, is serial interrupt RI and TI. Okay, I hope you all now understand the priorities assigned to the interrupts. Okay, now let's see the structure of the IP register. This is the structure of IP register, in which the upper 3 bits are reserved for the future use. The next 5 bits are PS, which is used for priority for the serial interrupt. Then the PT1 priority for the timer 1 interrupt, PX1 priority for external interrupt 1 bit, PT0 priority for timer 0 interrupt, and PX0, that means priority for the external interrupt 0. Let's see the details about each bit one by one. First of all, let's consider that priority bit equal to 1, that means, for example, consider PS equal to 1 means assign high priority. That means by giving one value we can assign it the highest priority. Okay, priority bit 0, that means PS equal to 0 means assigns the low priority. That means we can set the priorities to the interrupt as per our program. Okay, the PS bit is IP.4 and it is serial port interrupt priority bit. PT1 is IP.3 and it is timer 1 interrupt priority bit. The next is PX1 is IP.2 and is external interrupt 1 priority bit. The next bit is PT0, which is IP.1 and it is timer 0 interrupt priority bit. The next bit is PX0, that means IP0, that means external interrupt 0 priority bit. That means if we want to give a highest priority to the serial port or the serial interrupt, we know that the serial interrupt RI or TI has the lowest priority. But if we want to set a higher priority to this bit, then we can make it by simply assigning 1 to it, or by simply giving value to 1 it or setting it. Okay, I hope you all understand the IE and IP register of the 8051 microcontroller. Thank you.